Good morning, my name is Monica Pineda, and in today's video I will talk about Newton's first law of motion with some concepts and also some examples. Before I explain a little bit about the law, I need to explain who was Isaac Newton. Well, he was a scientist, a mathematician, and astronomer. He was considered one of the most important scientists in history. During his lifetime, Newton developed the theory of gravity, the laws of motion, which became the basis for physics, a new type of mathematics called calculus, and also many other things. But in this case, I'll just give a further explanation of what is the first law of motion. It's interesting to know that these laws have their own history because firstly, the first law of motion was proposed by Galileo Galilei in his dialogues. It was best known as the law of inertia. Inertia is the tendency of the objects to resist a change in their motion. So, as Newton refined these ideas, he states, if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at a constant speed unless acted upon by an unbalanced force. From this, I want to highlight two aspects. The first one is about the unbalanced force that he mentions. This unbalanced force is an external force that changes the state of motion of an object. Also, we can refer this as a net force because there can be a set of many forces. But another aspect is best shown in this diagram. Basically, what this wants to say is that, for example, objects that are at rest will have an acceleration and a velocity of zero because obviously they are not moving. And in the case of objects that are moving, they will have a zero acceleration and a constant velocity because they will be in the same direction and they will not accelerate. So this means that the forces that are acting in both objects are balanced. So now that I already explained a little bit about theory, I'll show some examples. The first one is objects that are in rest. The materials I use are a jar, objects with different weight, and also a plastic card. So the first thing that I make is to place the plastic card above the jar. Then with the different objects I choose, I place them above the plastic card. So for each one of them, I just push the plastic card to see what happens with the objects. So the question here is, what happens? Well, as I already said in the theory, objects that are in rest will keep in rest. So in this case, the objects that were the four of them just stay in rest as they were. They didn't change direction, they didn't move to any other place because they were in rest, but they also fell because of gravity. Now this example number 2 is also about objects in rest. The only materials I use here are a paper and also a book. The first thing that I make is just to place the book above the paper. Then I just push the paper. So this is very easy to understand. As I already said, objects that want to be at rest will keep in rest. So in this case, the only thing that moved was the paper. So the book stays in the place that it was because of inertia. Now for this example, which is number 3, I'm going to show the case of objects that are already in motion. The only materials I use were two eggs, but in this case both eggs have differences because one is fully cooked and the other one is uncooked, and also a smooth surface such as glass. So for this experiment, all I did was to try to turn both eggs and then stop their movement to see obviously there are differences between them. So what happens here? For objects that are already in motion, inertia dictates that they continue to do what they were doing. Therefore, in the case of the uncooked egg, even though I stop it, it did not prevent the whites and the yolk from continuing their movement. Therefore, it continues to move. But in the case of the one that is cooked, let's say it is like only a single piece, so it occupies a single force that makes it stop. And finally, in this last experiment, what I will show here will also be moving objects. In this case, the materials I used were some toys and also a type of obstacle such as a box. What I did here was to try to simulate a crash in a car. The explanation is very simple. At the moment in which the object, that is the box, or it can also be an external force, changes the state of movement in which the car was, another factor, that is the person, continues to do what he or she was doing, that it was going forward. And that's why the person shoots forward. That's why the seatbelt and the airbags are so important in real life.